All right, let's go ahead and we're gonna lift this off of our rollers here now. And we're gonna take our rollers outside and our indicator outside, and I'll come back and grab you and we'll go out and check this out. Okay, we're out here and I have the rollers set up about 8 inches or so from each end like we had before, just because I want to give this a mapping. All right, now we know that this roller is 0, this roller here is 0. Everything else is run out in relationship to those 2 points. As soon as those 2 points change, you know, the run out's going to change in relationship to where we're riding, just so that you know that the 2 points we're riding on is considered 0. It may have egg-shaped, or the material might be deformed or whatever. That'll give a variable of that 0, but right now we're just going to call it plain old 0. All right, I'm going to take and map this out about every 12 inches, and we're going to see just about where we're at here. Okay, 7, and I just put a 7 where the high spot is. All right, about another foot here, about 4. This 4 and that 7 are in line. I'm just mentally thinking of this as I'm going. This is all about mapping out your project here. 6, 7. I get about 7 right there. I'm getting about 6.5. I'm just going to write 6. All right, one more spot just in between here. It's not quite a foot, but it's there. There's 6. Okay, on the outside we got about 1/1000 right there. All right, outside over here, and this is the bent side that we thought we knew that this was running way out. Okay, so we got about 23 right here. All right, that 23 is pretty opposite to the 7. So when we take this out here, it's gonna better that. Now let's just say we're gonna be right in here where that taper is. See, that's still running out quite a bit right there. They do say cut it right there, and this is gonna be our length here. We may be really close right here to having the run out. We're going to double check our overall measurement. I think that right there is where it gets cut off. So this is material out here, this rounded in is not going to matter. And we have about 10 thousandths, 12 thousandths there, and we're running within about 3 right there. So our taper is going to be right in here. That's going to be machined off. So as long as we're grabbing this and we're turning that true with the rest of here, she should be pretty good. Okay, now that we mapped it out, we kind of come to our conclusion on what we're going to be doing on this end. We're going to be straightening out more of this, and some of this might even come out where it doesn't even, it's not showing a significant amount like it is right now. We're high here, all the way across here. This is 4, 7, 6, 6, and 7 here. So we want this really to go down. So we're going to roll this over, and on the opposite side, we're going to peen it so it'll swell up on this side. And we're going to work a little here and work a little bit down here, and we're going to bring it up together. All right, so now what we want to do is go ahead and find us a board, because I want to be able to lift this, slide a board underneath, because when you peen on this and it's floating, it's pretty loud, and I just want to deaden the sound a little bit. So let me go find something that's going to work, and then I'll come back. All right, the board that I was using to press on, turning it sideways, it lets you lift up and get a space underneath to go ahead and tap, and that way I'm just going to support it underneath the area I'm tapping, and that should deaden it enough. I'm going to have my hand on it also. All right, so here's our high here, and we rolled it over. We put a line on the end so we knew exactly where we're at. We're going to slide that underneath here, and we have our spot kind of marked out here. You start out gradual and you start working it, and then you put it down, you measure it, and then you find out actually how much you're needing to go ahead and peen or spread the surface. Now this is, I don't know, this ball peen I've probably had over 20 years. I've chipped the handle a couple times, you know, doing the soft blow, whatever it took to get it in there. I just went in and addressed this. Every once in a while you got to address it. You just want it nice and smooth, okay? You don't want to put any, you're not trying to texture the surface of this, all right? And then you just grab it firmly. And you just work back and forth, and then you work a little bit around there. In between your swings, you're directing where you want the next blow, but you're trying to keep it into a patch, and you're trying to work it out, because you're going to hand draw file. I shouldn't say draw file, that's sideways, but you're gonna massage it with your file and blend it with some paper and create a surface that you can live with. All right, now we just flip it down here and we put our indicator back on here. And we brought that 7 down to 3/1000ths. We just kind of want to pick and see what we're doing. Here's where the 4 is. Okay, we brought that 4 down to 2/1000ths right there. Now, of course, we haven't done nothing down here with the 6 yet. It's still reading 6. Okay, so we know we brought this down to 3, so we went about halfway. So that amount of tapping that we did on this side right here, we kind of want to duplicate that again. Now that time I was just trying to hit around the outside edge to just kind of push from the center where I was hitting on out. Meaning out from the center of impact that I was hitting. Okay, now we're down to 2. About 1.5. All right, we're within 1/1000ths there. Let's see where we're at on the 4. That's about 1.5 and or 1, and it's just slightly off of where the 4 was. Here's a 7. That's now at 3/4 right there. All right, let's go down here to the 6. And it's still a 6. All right, so the low is right there. Make sure we're staying on our zeros. Okay, we're at 2. We just need to go a little bit more. Okay, we're at 0 or a half or so. About 1. We're about 2/1000ths on that side. We're about 1/1000ths on that side. And here on the inside where we got a cut, We were riding about 7 thousandths right there. That's 5. Four. We're within 2 thousandths there. We're within 1.5 thousandths there. All right, I'm happy with this shaft. And if this was a marine shaft, this would be a true running shaft. And when we get in there to the lathe, you're actually going to get to see how this thing actually spins in the lathe now. And you could see that you wouldn't have been able to spin this thing up at 450 RPMs or so, or even faster than that, to do machine work with it bent 100 thousandths in the middle. It's just not going to happen. All right, let's go get her in. All right, we laid our stick drawing, our map, you might want to call it, out here. We're going to be turning a pinhole diameter down here, and then we have 4 series of holes that are going to get drilled and tapped. And I laid it up here because I want to make sure that I have somebody to answer that phone. Okay, pinhole, it's got to be machined on that end, and we have the taper and threads on this end here, and I marked it off to be about 1/4 inch longer because I want to play with the threads that we're going to be putting on. How I put it over here. This nut here has got a little bit different threads than what was planned or original on this taper here. And I want to make sure that they have enough, plus there's enough for draw. So they have a set height dimension that they actually want the collar to set, and we're going to be machining that into play as well. All right, now that I've confirmed what I want to put on there as far as measurements and everything else, we'll slip this into the lathe, and I need my junk rag here to cover up my roller. That's just so it doesn't scratch the material when I put it, pass it through the wall here. All right, I'll go around and get it put in through that side. Okay, we just pull it through the wall here and then steer it straight into the back of the lathe. And then gently make sure that we're going out through the front jaws there. And there we go. Okay, we're going to go ahead and we're going to be cutting this off first. So we're going to just grab it kind of short here. And I put a mark. We're going to be cutting it right there on that blue Sharpie. Okay, our rollers are set up in the back. We want to make sure that they're eyeballed to be center. We can tighten up on here, and there we go. Now you can see it running true here, but I'm also going to give you a perspective of actually looking at it and seeing how it rides on the rest of the setup out the back here. All right, now I'm going to turn it on. You'll be watching here, but also here's my roller here holding it center in the back here, and then the rest of that shaft is hanging free off the end of there. All right, now this is not shaking at all, and that is very, very steady. Now if you didn't have a straight shaft, that would be whipping around. This would be rocking and rolling and shaking and making noise like that. And let's go into the other side and we'll actually see how true it turns on the other side as well. Okay, now she's rolling pretty smooth right there. You can barely see it moving or deflecting or shaking around. It's almost perfectly true, and it's just a little bit on the end cut here that actually kind of looks funky. But this actually on the outside here is hardly moving at all. Let's zoom in a little bit on that. All right, let me set my coffee over here. All right, good morning. Sunday morning here. I finished up editing what we had in videos, and I was watching a lot of the footage after we put the material in there, and I started having static problems again with my little microphone. This little microphone, I was walking through the shop and whoa, it got snagged on the little lathe there, and it seemed to be working fine. Then it started acting up, and then it started working fine, and you know, it goes back and forth. And finally, I just analyzed everything, and the wire going into the little plug here had pulled, and that's what's causing the static. And that static is so extreme that you can't edit that out. And so I've trashed that microphone. I picked up another one. I'm still having a problem with it because it doesn't want to push all the way in and lock in, but as long as I'm not doing aerobics, we're going to be good with it. All right, now here's the thing. I'm going to go ahead and give you highlights of how that job finished up. Not that we know that we were just doing a taper, a thread, and a key, and some tapped holes and everything else in there, and there was some good things in there, but I'll just show you the highlights of there. Let's move on to something that I know that a lot of you, I've had requests for my little rollers, either how to make them, do I sell them, and the last suggestion I really liked, hey, you have a kit for those, or let's build a kit. And that's what I'm thinking. The average Joe out there, hobbyist, or just one-man shop, just as my own, if you were to make a set of these, you have to buy the materials. And of course, some of the materials you can only get in full lengths, okay, like box tube and things like that comes in 20 or 23 foot lengths. And so the expense of actually making a set of rollers, unless you can go and comshaw a couple cut pieces here or there, or some of the flat bar, that's no problem. Usually you can mill down something thicker or bigger that you got, and you just live with the time that you ate up. But if I was to procure a link to the box tube, the bar stock that needed to, the bearings, the stainless steel axles, the stainless steel nut and bolt combination that goes through there, and the stainless steel little square pad on the side. These are things that I incorporated so that they don't rust, because I use, you know, these are submersible and everything else, and they can be left out in the rain, and when I do heat straightening, they do get wet and stuff like that. So what I'm going to do is I'm going to go ahead and give you a demonstration of how I use these rollers, why they're so great, and you don't need to have perfect level surface. I can actually go out on the site and get down on a concrete slab somewhere in somebody's building, or on a wooden floor that's you can't have rock and rolling, because that'll be fluctuating. It'll be like, I've used them a couple times on my rubber mats inside the shop. As long as you're comparing the whole thing overall, and you move very gingerly, you can still get a readout in those cases. But for just like concrete floors and everything else, they're not perfectly level. So what I'm going to do is I'm going to go ahead and take this. I'm going to bring you in closer, and I have several short pieces of materials here, some large, down to 3/4 inch. I made these to be minimum 3/4 inch capabilities, because that is basically the smallest marine shaft that I work with, and then on up. And I've actually rolled 9-inch by 14-foot shaft on these rollers, so they are stout. You know, you can't drop that shaft on these rollers, but you can set it really lightly with an overhead crane and put it on these rollers, and you can do the job that needs to be done. All right, so let me bring you in close, and then we'll get with the demonstration of these rollers. All right, let's go ahead and we'll grab this big dude here. I'm going to set this up on here, and I think this is 2 3/4 inch diameter. This is going to be a pair of rudder posts, and we don't really need to have these straight or whatever, but they just happen to be in here, and they show a really nice large sample being run on these rollers here. Now, once I set them on the rollers, I stare down and I visually look at making sure that the rollers are 90, and sometimes you can really feel it on how ease that they continue running. And also, when they are straight in line and you're in fairly level surface, they don't track side to side. And then you can go ahead and you can set up your indicator, and you can see I'm not even getting a readable amount off of this diameter here, because this is running pretty true for this short diameter, which is that's about 24 inches or so. So when you're reading shafting, and we know that this is 0 and this is 0 in relationship to your two rollers, or as if they were V blocks on a precision table. Now I'm reading probably 1/10 or 2, the indicator just barely moving. Now, it doesn't really matter if I'm sitting here in this level plane here, or if I was to go ahead and take and set up a raised surface on one side, or one side was a little higher than the other. As long as the rollers are in line, the trunnion action of the caster that I put in the side of these rollers allows those two bearings to flat out parallel to the axis of the shaft. And that is why you don't really need even or level flooring or anything, a beam. I used to straighten at some of the shops I learned on a really nice big I-beam that was about 20 foot long, and had a nice wide flange, real tall set legs, everything else. It was really nice to go. And I kind of just threw this together when I first started my business here on the Cape, and it's worked out really well for me. And I have no problem. Sometimes I have a lot longer shafting, and sometimes I have to switch it side to side. Sometimes I actually got to get something to hold my indicator. Now, my indicator plate is this is actually this stare push button does not push anymore. Okay, it is locked on, and you have to physically pull it off. This is just a saw cut slab, and then I took and I spot welded 3 points on this bottom, and I took it against the sander and I hit it so that I have 3 flat little pads down here, so that when you set it on any surface, it automatically stays stable. All right, so that's another trick to do for an indicator that you're going to be moving around by hand. All right, so now we have something offset here. The natural weight of the material will always want to go downhill. That's just physics, and sometimes that actually comes in handy. And I'm going to go ahead and I'm going to switch this around just so that you can see it off your side there. I'm moving this over to this edge right here because I don't have an area right in here that I can clamp. But let's say you're going to do a shaft, and that shaft has a flange. You've got center holes in your shaft. Okay, you can take a ball bearing, you can put it in the center of your shaft. Okay, you can take a ball bearing, put it in the center of your shaft, and when you roll it, your natural weight is going to be wanting to roll downhill, so it's going to hold your in thrust. Then you can take your indicator, you can turn it around, and you can read this face right here, and then you'll be able to read coupling faces. So there is advantage of purposely setting it off level, but most of the case you're going to want it, level, just because the travel you want to keep your zero when you're working your shaft and you're not really paying attention to its travel, but you're working different diameters. We know that this is 0 and this is 0, and you're straightening everything in relationship to that. So if this is traveling, your zeros are traveling, and you'll chase a ghost sometimes. So just making sure that you're not traveling side to side every once in a while. I mean, you can work a spot and then you just double check, and you can look, you know, mark your zeros on there with a little felt marker. So anyway, that's one way to actually control in thrust and actually use it to indicate off the end here. Don't want to lose my bearing there. Now 3/4 inch is the largest, or 3/4 inch is the smallest shaft diameter that I can run in these, and that's why I got these kind of milled out down in the valley here. And this bolt that goes through with these two plates is basically just sandwiching the shafts going through the bearings so that they don't pop out. And so there's 1/4 20 bolt going through there, actually holds the whole cluster of bearings together. So you pull that off of there, you can pull your bearings out, slide them out. I've actually replaced these bearings a couple times, just because over the years surface rust on the outside, and I do polish and clean them and I lube them, but you do tend to wear out from rolling. Not everything that you roll is perfectly smooth and finished on the outside. Sometimes you're running and you got marine growth and everything else that's on there, but you're trying to stare and see that, you know, hey, that 1/4 inch are running out on the prop end, or you know, you physically want to witness what you have by the naked eye. Because most bends, when you're looking, when you know something is bent, you're kind of making a first judgment on that as well. Then you can fine tune your straightening after the fact, and then you clean up your shaft, you're running smooth and everything else on a roller. So just every once in a while you do have a little bit of less than ideal surface coming in contact in my trade. All right, so it really doesn't matter what diameter. Oh, that's a pretty good whip there. And these are just random pieces that I have in the shop. This is actually a piece of 304. Okay, now you've seen my T-stand behind my lathe. This is the mate to it for the stand that's on the other side. That the floor is a little high, so I can't actually fit this in there in the stand, which I like to remedy that when I'm in there setting some of the foundations for the little machinery I plan on moving around this summer. And I'm also like to put that stand down to where it's level, and then I can mount my secondary roller. But I also use this roller in for my weld positioner, usually to hold long lengths of shafting. If I'm doing a weld fusion overlay process on them, I can do it there. And that's another reason why the trunnion really does work out beneficial when you got a bench, you got a welding positioner, and you're working different diameters. The angle of the dangle is coming off of the well positioner is got to be running true, and wherever that is, this trunnion action on the roller can self-align itself with the axis of the shaft. All right, I want to bring you in close, and I'm just going to take this one here. I'm going to bring in the camera real close, and I'm going to kind of show you a real close-up of the trunnion action and kind of a little bit about the build on the bearings here and how they're mounted and the action of the trunnion, and then we'll go in for a discussion on who wants to receive a kit, and we'll go from there. Okay, now this standard bearing that I use out on the table was welded to a plate so that I could bolt it to my stand. So that's the difference between this one and one that you see underneath the marine shafting that I have behind it. Now, I brought you in close to show you. I got two center holes that they're actually like oil cups, and they were just using the center drill. And so we put a drop of oil in here, and we'll drop of oil in here. We haven't put any in a while. Okay, so anyway, we're just kind of rolling those around. All right, so I built it so that you can lubricate your pivot on the trunnions, and the weight and everything else will cradle and keep that action working freely. And every once in a while you oil them, and you roll it around and get that oil to flow down in there. All right, this trunnion pin and an inner block inside the end of the tube, and then they're welded in on the top and bottom here, and then I finished that off with sanding. So that's actually how the trunnion mounts into the block. There's two plates on each side, and they're sandwiched with a bolt and a standoff in the center, so that center of the box tube does not expand or collapse. And then the two bearings are precision bearings, rubber lip seals, so that fluids and stuff like that can't get into them. It is the simplest design, and the strength has been proven in, I don't know, since 1991, since I built them. Okay, that's kind of a quickie glimpse, and why I really designed and built these rollers the way I did, and the reason was the most common use was marine shafting, but they do play in, I mean, I've had crankshafts rolling on it, I've had a lot of precision rolling items on these set of rollers, and have proven trueness, either needing to be straightened or bent beyond repair. Whatever your purpose or your need for your rollers are, this is a great set of rollers to have on hand. Now, what I'm saying is I am going to go ahead and go through and create a video in building a set of rollers, and if I have enough interest, I will go ahead and I will procure the material. I will put up a reasonable price of costs for putting the kits together, just a bare minimum price for the material as I get it in full lengths, and what it takes me to go ahead and dice it up and package it and send it, and then you would have a kit ready to go to where you'll be able to follow along with my video that I create. And during the video I'll be offering the kits as well, probably. All right, let's bring this to a wrap here, and basically I'm just asking who's interested in kits and making it worthwhile to go ahead and pick up enough material so that I can absorb the quantity of materials that it's going to be needed to actually pick up and make a set, and offer the drops from the full-length materials as kit projects, and put the kit project together so that you can follow along with the video and create your own set of rollers. Also, this will be leading into later on, and I'm not sure what format, where I'm going to release them, or what's going to be happening on my straightening video courses that I'll be putting together. And what a better way to go through those courses and having a set of rollers that will do the job that you can practice along with those courses as well. All right, until next time, next video, get her done. We'll go ahead and we're going to give it 20 thousandths. This is what I really like to see. When you got a nice true shaft, and of course we know that we had a little bit of a blem because this was the drop end or the extruded end of the rod. It was one of the blank or the natural ends of the rod, and that section of rod, sometimes it's only a ½ an inch, sometimes it's 3 or 4 inches, depending on the stock and how they run it, whether you have a deformed end. The rest of it is the reason why they call it cold roll, is because it's precisionally rolled in a smooth fashion, and it's to size, and it's usually pretty straight, except for, well, you saw how straight this was when we started, but we got it down to where it's really nice and straight. And the major diameter of any taper coming onto a straight actually kind of visually lets you know how close you are. If it's, the more it's rocking out, the farther off it is. Now we know that we have a little bit of blem, and as it's coming back in this area here where the major diameter is actually going to be, we do have a little bit of a peening that's going to be there, but the overall should be running really true. All right, so we pull this back, we come back to our 0. Now if we're stopping to check our size, it was 1.5 inch, we took 20, and we're right there at 1 inch 460. This really is pretty accurate. I mean, when you want to take 5, it takes 5. You know, if you want to take 1,000 or 2 thousandths per side, I have really good response. Once you've made your initial passes and the tool pressure's all in place, this thing repeats or takes what you want really nice. Another 20. I'm just putting a little oil on here just to ease the cut itself. That line's even staying more and more true as we get to where we set up for the center hole in the end of the shaft to hold everything, and that's really looking good. All right, this is another 20, and then we'll check it. Okay, this is 1 inch 380. This should be pretty close to being right on the money here. Okay, we have just a little tiny bit of rock, but we've got a good draw right there. We want to end up having about 100 thousandths draw, maybe 80 thousandths draw, just as much as the bore that we can get on there. All right, so we're a little bit high, and I'm going to go ahead and take a look at my marks in here. You know, I'm almost tempted to do a light lap on it right now just to see, because I'm rocking side to side, but I'm not rocking up and down, and I think I think we're really tight in by the key and this other section over here. That's what I'm going to do. Alright, I'm just putting this down here so I don't put any, drip any compound in on the ways area. I'm just using, this is a coarse 120 oil-based lapping compound, and I'm going to want to go slow. I could break that edge on the end there, but I'm going to leave it right now because I would just want to make sure that whether that is our contact area or not our contact area. Now by holding this just by hand, go in, make contact, let it roll around, come back. Wipe on wipe on the unused compound. Okay, that should be enough to give us a highlight of what we're actually making contact. I'm looking at two different places. I'm looking at my grip pattern on here, and this is coarse. And then I'm going to look in here on my bore. See if I can bring you in here. And let's see if we can. Okay, there's a little patch right there. That is making contact, and then 180 from it, you see both sides of this keyway right here is making contact. Now almost the full length of the key is making contact. There's a little spot right there at the major diameter, a little spot there, and the same thing over there. This is kind of right in the center there. I think I'm going to lap this for a little bit, see if I can get a better bore in here before we continue or take any more off of this here. And before I start lapping again, I'm going to go ahead and kiss that leading edge so that we don't lap that sharp edge into here. And then we'll go back to taking a couple more skim cuts until we get our draw down to where we want it. We probably have twice as much or a little bit better than that as far as draw. Draw is the amount of distance before you bottom out your threads or your nut against the minor diameter of the shaft right here before it touches here. So the difference between this face and that face is called the draw, that space that you have to draw it tighter. This is my junk file, and the reason why I call it my junk file is it's the one I usually always hit the corner edges. Because it lets me apply the pressure and not really care too much about the file, and meaning it gets loaded up and all kinds of other things, but it really does suit the purpose for just knocking the edge off of there, and then I can clean. This file becomes this file when it's no longer a good quality file in a lot of other purposes, and I just kind of always keep that in the bed of the lathe here. Okay, I just took this over the vise just to let you know what I was doing without hiding or without skipping showing you anything, but I went ahead and took my flapper wheel and I hit it hard on the key area. I flipped it over and I hit it hard where it was touching. This is areas that I know that needed to be worked. This is smooth and round, and this has got the high spots in it, so I was massaging the high spots of this to kind of speed up the process. I mean, we can sit here and we can lap this all day long, but that's not what I'm striving for here. All right, kick it back down in a low gear here. Second application. All right, let's wipe her out and see what we got. Just by kind of reading the lap pattern on this here, I can see that we got a good contact angle. So let's just see what we got for high spots in here. Or if it actually started picking up all the way around. You know, that's looking pretty good there. Let me bring you in and see. Okay, I'm gonna roll it around. There is one little hollow right there. It's light right in there, and it has one little spot right there. Those are divots. Making good contact on both sides of the keyway. It's rolled a little bit, but that's okay. I'd rather have you know, that little bit of clearance there and making good contact out here than vice versa, making the hard contact there and nothing out in here. I want the taper to hold. I want the taper to do the job it's meant to do. All right, now we can go ahead and come in and let's take a real light pass on here, and let's get the draw a little closer, and then we can just do a quickie lap on it and we're going to be good to go. We've cleaned up all the imperfections in here pretty much, and I just want to get it down a little bit closer, and then we know that when this is mounted on there, it's going to be a good hold. Let that run. That's like a spring cut. All right. I just want to slip on the collar now. You know, when I rub it there, I can see that we're making pretty good contact right there. All right, I got probably 100 thousandths of draw there. Let's take another couple. Come back to our 0. All right, I'm gonna feed in 2 thousandths. That'll be 4 on the total. Shooting for a pretty good finish here. You know, really can't ask for much better line right here. And you see the hand. This is where I hammered and peened. There is one little area right in there, one little area right there. But that's where I had to peen it to get the end to go straight with the rest of it. All right, let's check the fit again, and I think